All right, welcome to this explainer. Today, we're going to take DevOps, which, let's be real, can often feel like a totally confusing buzzword, and transform it into a practical step-by-step roadmap that you can actually follow. If you've ever felt completely overwhelmed by the sheer mountain of tools, frameworks, and conflicting definitions floating around out there, well, you're in the exact right place. We're cutting right through all that noise to give you a clear, actionable path forward in the fast-paced world of modern software engineering.
So, let's dive right in and ask the million-dollar question. Why exactly are companies paying top dollar for DevOps engineers right now, especially with cloud computing and AI taking over? Well, it's pretty simple, really. Modern software demands speed and reliability, and it demands it on a massive global scale. Because of the explosion of microservices, where these giant applications are chopped up into dozens, maybe even hundreds of tiny independent pieces that all have to constantly talk to each other, organizations just can't afford the old, slow, manual ways of doing things anymore. They desperately need experts who can bridge that massive gap between writing code and actually getting it to run smoothly for millions of users all around the world.
The absolute crucial point to understand right out of the gate is that DevOps, it isn't just a single tool you can go and download. It's actually the structural solution to a massive historical pain point in tech. For decades, developers would just sit in isolation, write their code, and then essentially toss it over a metaphorical brick wall to these struggling operations teams, basically saying, "Here, you deploy this, it worked fine on my local machine." That whole dynamic created terrible friction, agonizingly slow releases, and honestly, a whole lot of finger-pointing when things inevitably broke down in production. So DevOps is the literal dismantling of that wall. It's about creating shared ownership from the exact moment code is written to the second a customer actually uses it.
All right, stop number one. Culture eats strategy first. This builds the very foundation for everything else we're going to talk about. Because honestly, learning a bunch of random tools without the right mindset, that's just a recipe for disaster.
It's a proven reality that a truly good culture can actually work around broken tooling. But the opposite? Yeah, that almost never holds true. I mean, you could go out and buy the most expensive enterprise deployment software on the planet, but if your dev and ops teams still hate each other and refuse to communicate, your software releases are still going to be a total mess. The technology we use in DevOps is really just an enabler. It's the culture, the collaboration, the psychological safety, that shared responsibility. That's the actual engine driving a successful engineering organization forward.
Moving right along to Section 2, building the CI/CD pipeline. Now that we've got the culture side down, how do we actually go about automating our code integration? Think of this like a giant software factory assembly line. Your code actually travels through 4 continuous phases. It kicks off in the source phase, usually a version control system like Git, where a developer commits their fresh code. Then, boom, it automatically moves to the build phase, where that code gets securely packaged up into something like a Docker container. And hey, if you're newer to this, a Docker container is essentially just a lightweight, standalone package that holds absolutely everything needed to run an application. It guarantees the app will run exactly the same way on any machine in the world. Pretty cool, right? From there, we enter the test phase, running functional and regression tests to make sure nothing is broken. Finally, if it passes all those tests with flying colors, we hit the deploy phase, seamlessly pushing those shiny new features out to production.
By completely automating this pipeline, we totally eliminate that old, clunky, siloed way of deploying software by hand. I mean, think about it logically. Every single time a human being has to manually copy files over to a server, there's a huge risk. A typo, a wrong directory path, a completely forgotten configuration step, it happens all the time. But a CI/CD pipeline, it does that exact same process millions of times without ever getting tired, getting distracted, or making a single mistake. It is absolutely the backbone of a modern, reliable release schedule.
All right, Section 3, Infrastructure as Code and GitOps. Our code is fully automated now, so let's level up. How do we automate the actual servers that this code runs on? So the crucial point here is that we're shifting away from artisanal, hands-on administration over to programmatic, repeatable provisioning. Back in the day, if you needed a new server, an admin would literally log into a console and manually click a bunch of buttons to set the whole thing up. And let me tell you, that process is incredibly fragile and super hard to track. But with Infrastructure as Code, or IAC, you just write a simple configuration file that declares exactly what you want. Like, hey, give me 5 virtual machines and a load balancer. You execute that code, and boom, the infrastructure spins right up automatically. It's fully documented, easily duplicated, and it's what the industry calls idempotent. That's just a fancy word meaning you can run that exact same script over and over and always get the exact same completely predictable result.
Now, GitOps takes this whole concept a massive step further. By using tools like Argo CD, it ensures your live environment always matches the exact state declared in your Git repository. Imagine someone logs into a live production server in the middle of the night and tweaks a firewall setting. Well, that creates configuration drift. Your live server suddenly doesn't match your source code anymore. Not good. But with GitOps, an automated software operator is constantly checking your live server against the code stored in your Git repo. If they don't match up perfectly, GitOps instantly and automatically overrides that manual change to restore the desired state. It essentially forces every single infrastructure change to go through proper, documented code reviews. It is a real game changer.
Moving into Section 4, Monitoring and System Observability. Okay, so everything is automated and deployed. Awesome. But now we have to make sure it actually works out there in the wild.
Let's look at the harsh reality of what happens when our systems inevitably fail, and we'll use a real multi-hour catastrophe as an example. In December 2021, a massive Amazon Web Services region went completely dark. But what made this so incredibly painful for the engineers wasn't just the downtime itself, it was that the outage actually crippled the exact monitoring tools those engineers rely on to see what's going wrong in the first place. Honestly, you simply cannot fix a massive system failure if you are completely blind to the metrics.
When we trace the timeline of this outage, we see that unprecedented network congestion actually caused the monitoring data itself to fail. It proves the ultimate DevOps golden rule. If you can't see the problem, you absolutely cannot fix the problem. The incident response teams over at AWS were effectively flying blind all morning and midday because that internal network congestion choked out their own real-time telemetry. It just highlights how absolutely undeniably critical a highly resilient monitoring architecture is to your entire system recovery process.
And here is where we see a massive difference. Monitoring tells you if the system is broken, but observability gives you the deep, actionable insights to find out why it's broken. A standard monitor will just page you at 3 a.m. to sound an alarm like, hey, CPU usage is currently at 100%. But a truly observable system gives you the granular logs, the detailed metrics, and the distributed traces, so you can look at it and say, okay, the CPU is maxed out because this specific new line of code we deployed yesterday got stuck in an infinite loop. Observability lets you answer those really complex questions about your app's behavior and even forecast what might go wrong next.
And that brings us to our final stop, Section 5, your complete DevOps roadmap. Let's see exactly how all these puzzle pieces fit together into one unified journey.
By following this roadmap in this exact order, you can literally transform from learning basic Linux terminal commands all the way up to deploying highly complex, self-healing Kubernetes clusters. You see, you don't start by jumping headfirst into GitOps. No way. You start with step 1, deeply understanding the Linux fundamentals that run everything under the hood. Then, step 2, you learn shell scripting to automate your basic admin tasks. Once you're comfortable there, step 3 is building CI/CD pipelines to automate your code integration. From there, step 4, you tackle infrastructure as code and GitOps to fully automate those servers. And finally, step 5, you wrap that whole entire ecosystem in robust monitoring and observation so you can easily manage these complex distributed systems without breaking a single sweat.